All right, so I have made available two different forms, so two different PDFs for you on our VCHS.net site under this AP exam prep section. So first thing we're going to look at is this AP exam breakdowns document. Apparently I'm not logged in. There we go. So this document is going to be an overview of what our actual exam is going to look like on the day that we take it. So our AP score for this class is going to be defined by our multiple choice section, going to be worth 70%. There will be 70 multiple choice questions, and the other 30% is coming from our create performance task. So we've been working on the create performance task for a while, and that's going to be worth 30% of our total AP score. On the actual AP exam, you're going to have a bunch of single select questions. You'll have about 60 of those. You'll have 5 single select questions with a reading passage about a computing innovation, and you'll have 8 multi-select where you'll have multiple answers you can select to submit your answer. You'll have 120 minutes to do the multiple choice section when you take the exam. Here is just a bit of weights on how many different questions you're going to get within different things. So a lot of questions are going to be focused on algorithms and programming and the impact of computing. So we're going to focus on algorithms and programming a little bit today. We're going to talk about what those questions are going to look like. For the reading passage and then answering questions, they have an example of what that kind of question might look like. So let's say our reading passage is a chain of retail stores uses software to manage phone calls from customers. The software was recently upgraded. Customers interact with the original system using their phone keypad. Customers interact with the upgraded system using their voice. The upgraded system, but not the original system, stores all information from the calling session in a database for future reference. This includes the customer's telephone number and any information provided by the customer: name, address, order number, credit card number, etc. The original system and the upgraded system are described in the following flowcharts, where the flowchart uses these blocks. An oval is the start, parallelogram is an input or output, diamond is a decision, and a rectangle is the result. So here's our original system. The customer hears the pre-recorded message with questions to answer. They hear a list of departments and selects one on their phone keypad. If the call is during business hours, they'll be transferred to a representative. If it's not, they will be transferred to, or they'll be asked to leave a message. So the upgraded system is much more complex. The customer is going to describe their issue. If the system can identify their issue, they're going to check, does this require a human response? If it doesn't, they're just going to play the appropriate recording. If it does, and it's within business hours, we're going to transfer to a relevant department. If it's not during business hours, we'll have them leave a message. If it's not during business hours at all, and the system can't identify their issue, they'll be transferred to someone. And if it's not during business hours, they will be asked to come back during business hours. So that is our reading prompt, or a sample reading prompt. All of those reading passage questions are going to be worded kind of similarly. You'll have some kind of an innovation presented to you, and then you'll have questions asked in these kind of style. Which of the following input data must be obtained or is needed by the upgraded system that wasn't needed by the original system? What kinds of things are most likely or least likely to be included in the directory? So taking the information that you're gaining from this reading passage and answering questions. So there's going to be 5 questions of that style, and there's going to be, I believe it was 60 some or 50 some odd, 59 57. 57 regular multiple choice questions about programming, the internet, all the other topics we've covered so far. And there's going to be 8 multi-select questions. So that's what our exam is going to look like overall. The next thing we're going to talk about today is the exam reference sheet. I believe that this document will be made available to you while you're taking the exam. But the AP exam, the AP principles exam, isn't in any specific language. So they have their own unique language thing that they use when asking questions. So I believe there's been a couple of questions during our time on CodeHS that have had this format, but we're going to go through all of the different instructions that exist and describe their analog in Python so that we know exactly what our different things are, so that we can be prepared to see them on the actual exam. So, very similarly to Python, this language doesn't care about defining the type of its variables. We can just say, I want this variable to equal this value. And we use that left arrow sign to do an assignment. We're going to assign this value to this variable. And another thing, on the exam, you'll either see questions in text or in block. They're both possible to see. And we're going to look at some sample questions later today, see how this might actually look. But we have the arrow. This is very similar to in Python, we use a single equal sign to do an assignment. If I want to have something display, if I want to have something print, display is the is what we would use print for in here. Now, the difference between print in Python and display is print will insert a new line. If you print something, the next thing you print out will be on the next line of output, where when you display, it'll be followed by a space. So that's important to keep in mind. Display adds a space at the end. It does not add a new line. Input accepts a value from the user and returns the input value. Very similar to Python. That one's not super different. Our arithmetic operators, let's do it math, those are all the same. We have our plus, minus, times, and divide. Those use the same symbols as before. If we want to do modulus, if we remember in Python, we use that % symbol. On the exam, you're going to see that mod word. It'll say mod when it wants to do a modulus. And random number generation. This is very similar to our random.randint method from Python. So random.randint, because we get 2 numbers in our randint. We get our start, comma, end as our parameters, and both are included. Just like in our random.randint, both A and B are possible values from our random call. So random 1, 2, 3 could be 1, 2, or 3. Each one is equally likely. Any questions so far? Is all making sense? Well, we'll look at some actual questions in a minute to see how these are actually used. Our Boolean and relational operators. The symbols on these are slightly different. Instead of using a double equals to do a comparison for the same, we use a single equal sign. Instead of using a not equals, we just put a slash through the equal sign. And then they combine the greater than or equal to and less than or equal to into that single symbol. So the operators work exactly the same as in Python. Just keep in mind that these symbols are slightly different from what we've been used to seeing. We have and, or, and not. Once again, these are very similar to Python where they use the actual word and, or, and not. So you should be pretty familiar with how these work. You should know how and or not work from back in that section. We have if statements. These work just like in Python. The main difference is that we're going to see those parentheses, and unlike in Python, we're going to use curly braces to encapsulate the block of statements. In Python, we use indentation to show where blocks are. In here, we're going to use curly brackets. And the block version, we're going to put that condition in this little slot, and then any code inside the if will be in that area. We can also do if else, and I don't believe there is an else if in this of code. So no else if. I believe it would just go. You have a second if inside of the else block, or inside of the else block, however you wanted to do it. Now, I don't believe you're going to be asked to write any code for this. It's all multiple choice on the exam. So you don't need to know how to use this to write it, but you should be able to read it and understand what's happening. Repeat n times. This is going to, very similarly to a for loop, it's going to repeat whatever block of statements that number of times. To my knowledge, that variable n does not change through the loop. Unlike when we do for I in range. That variable is going to be updating each time through the loop. To my knowledge, this doesn't actually have an iterator variable. It doesn't have a way to keep track of what number we're on. So we would have to have a separate variable to accomplish that. And then the repeat until loop is similar to a while loop, but it's kind of the opposite of a while loop. So instead of repeating as long as the condition is true, it's going to repeat until the condition becomes true. So think of it as a backwards while loop. It repeats as long as the condition is false, and then when the condition becomes true, it will stop. But the timing of a repeat until is going to be just the same as a while loop. It will only stop looping when it checks this condition. So if there's code in the loop after, it's not going to skip running that. It's going to keep running until it gets to the top, checks the condition, and it is true. All right, we can use lists in this programming interface. It's going to be defined by those square brackets, just like in Python. If I want to define a list, say square brackets. If we want an empty list, just make an empty set of square brackets. In this version, in this language, copying a list, saying B list or A list equals B list, essentially, we're going to copy our B list into a list. So changing one won't change the other, which is very convenient. Accessing a list just the same as in Python. So that one's not super confusing. Same as in Python as well. We access using that square brackets. We can assign to a new variable, or we can assign a value to a specific index. The insert method, we insert into this list at this index, this new value. This is very similar to the my list dot insert in Python, except we're passing the list as a parameter to insert rather than calling insert on our list variable. Otherwise, it's going to work exactly the same. We're going to insert that new value so that it has index I. If we append, that's just the same as in Python as well. We're going to put that value at the end of the list. The remove will take that value out of the list like you would expect. Our length, going to tell us how long the list is, also pretty self-explanatory. We can also do a for each type of loop. So if we remember how we did this in Python, we said for element in my list, do something. So we can do that same thing, except instead of just saying that, we have to use that each keyword. We say for each element in my list. And then that's going to do that same type of thing. We can use that item in our loop, and it'll be whatever that value was within that list. All right. In this language, functions are called procedures. So if I want to define a new procedure, if I want to define a new function, in Python, we said def my function with parentheses and whatever parameters. Here, instead of that def keyword, we use the procedure keyword, and then the name and the list of parameters, and then whatever it does. So biggest difference here, we're using the procedure keyword instead of the def keyword. But in both cases, we're creating a function, creating a procedure that we can call down the line. We can return just like we would return in Python. So return is going to be in all caps, but it's going to return some value from our procedure. How do we call methods? That's the big question. Okay. So calling a method looks like this. We just call the name of the procedure with parentheses and whatever arguments we want. So just like we would call in Python, we can call here. Now, something that we haven't really covered is this idea of a robot. There'll be questions where we're given some grid with a robot standing in it. We'll know which direction the robot is facing. So there'll be a little triangle showing which direction the robot's facing. And we might be asked to get the robot from point A to point B, or we might be asked which paths will get the robot from here to there, things like that. So the methods that we have access to with the robot are move forward. It will move that robot one square in the direction it's looking. We can rotate left, which will make it turn counterclockwise to look. So we want to move, it'll just rotate. So it doesn't change squares, it just looks a different direction. Rotate right. Once again, that'll move it the other direction. We can't move backwards, I don't believe. Yeah, we can only move forwards and rotate. So if we wanted to go the other direction, we would need to rotate right or rotate left twice so that we're facing the other direction. And then our last little block is can move. This will tell us true if the robot is able to move forward, otherwise it will not. We're going to pass a direction saying, is the robot able to move this direction? So can the robot move forward? Can the robot move left, right, or backward? So it's not only going to check directly forward, it's going to check whatever direction you pass here. Okay. Any questions on any of the syntax here? Now it's a little different from what we've covered so far. Not Python. Okay. I'm going to pause my share. Going to open up this quiz. All right, so we are going to walk through one of the prep quizzes together. I have gone ahead and unlocked it. It is in the APCS Principles Exam Review Unit, Module number 2. We're doing quiz 1.2.1. What does this algorithm do? Feel free to follow along so you can see the questions on your own device. And section 1.1 is just that same exact AP review sheet or reference sheet that I've linked to on our going to be assist on that page. So let's look at this question. Considering this code segment, temp equals x, x equals y, y equals temp, what is this program doing with variables x and y? What is the goal here?
To swap the values.
Is to swap the values. So we're trying to swap the value of x and y by storing it in the temp variable and then moving it over. So the program swaps the value of x and y. That is absolutely correct. All right, question 2. Display what is your name. Name equals input. One other thing I did not mention is that input doesn't have the ability to do a prompt. So if we want to prompt the user beforehand, we're going to use a display. So we display what is your name, we ask the user for input, we display hello, and then name. So if the user inputs Carol into the program, which of these will we expect to see? Does display add a new line after its value? No. Display adds a space. So the question is whether the enter from the user typing something in goes to the next line. So we know that it's definitely not this one because this between hello and Carol, there shouldn't be a new line. So it's definitely not that one. It's definitely not this last one because we didn't have that display what is your name. So it's between these two. And to be perfectly honest, I'm not 100% sure of the answer. So I'm just going to 50-50 it. I'm going to assume that the user typing something in and pressing enter doesn't go to the next line. I'm going to assume that it's this one, and we're going to verify. Correct. Okay, so under no circumstance here are we going to the next line. We did not print any new line characters. When we did that input, the user typing something in and hitting enter doesn't cause the input or the output to go to the next line. So our full output is all going to be on one line here. What is your name? They type something in. We say, hello, Carol. Make sense? All right. All right. We have a mystery procedure. We are getting a number as a parameter, and we are going to return number mod 2 equals 0. Now remember that a single equal sign is the comparison rather than a double equals like we would see in Python. So 1 equal sign is the same as 2. So we're checking if number mod 2 is equal to 0, and then we're going to return true or false. So here we are returning whether or not the number is even. True or false, is this number divisible by 2? All right, in this program, the initial value of A is 0 and the initial value of B is 1. So let's follow this through. If B equals 0, that is not true, so we're going to enter this else. If A is 1, that's not true, so we're going to enter this else. So we will display dog and we'll display turtle because that is inside of the else. So we will see dog, turtle. So these questions have been pretty simple, but it will likely become more complex. Consider this code segment below. We are going to get a number. We're going to display the word wow, and we're going to repeat some number of times. We're going to display exclamation point. So if I get an input of 3, we're going to see wow, space, and then exclamation point, space, exclamation point, space, exclamation point, space. Because display puts that space instead of a new line after its output. So we will see wow, exclamation point, exclamation point, exclamation point, separated by spaces. Wow, correct. And that was awesome according to CodeHS. Thank you. All right, if we look at this code segment, x equals random 1, 10, y equals random 10, 20, display y or x equals y. What best describes the behavior of the code, of the V code? Wow. Will this program always display true? I have a random number between 1 and 10 and a random number between 10 and 20. No, definitely not always true. Will it always be false? Also, no, because there is the possibility that x could equal 10, and then y could also equal 10, because they're both a possible value here. So both of them could equal 10, although that's not very likely. So our program could display either true or false, but it's most likely going to display false. And I don't see any problems in this code, so our code is not going to error out. All right, consider the code segment below. We have a mystery procedure again. We have a word and a list as a parameter. For each item in list, if item equals word, return true. And then after that loop, we return false. So what is this method? What is this function? What is this procedure doing? Looking through every single item. If it's what we're looking for, we return true. So it's going to just return whether or not that item is present. If it is, we'll return true. If it's not, it won't. And that's all we get. We don't get a number. We don't get an index. All we get is whether it's present or not. All right. For each item in the list, well, we're getting two parameters, word and list. X and Y both equal 0. For each item in list, if item equals word, we're going to increase X by 1. Else, X equals 0. if x is greater than y, y equals x, and we're going to return y. So we are looking for the word Carol in this list: Carol, Carol, Tracy, Carol, 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 Tracy. So let's just trace through this. Let's go step by step, see what happens. My word is Carol. That's my list for each item. If item equals word, Carol does equal Carol. So we're going to increase x by 1. We're not going to else. If x is greater than y, which it is, y is going to equal 1. We go to our next thing. X goes to 2, y goes to 2. We see a Tracy. X becomes 0. So x is back at 0, y is still 2. Then we see a Carol, Carol, Carol. In each of these, x is going to increase to 1, 2, and then 3. After x increases to 3, y is going to increase to 3 as well. Let me copy it. We see a Tracy. X becomes 0, y stays at 3, and then we return y. So we will see, we'll return that value 3. All right. Mystery x. Result equals 0. Repeat 5 times. Result equals x plus result. Return result. What is this equivalent to? Well, let's say x is 2. Result starts at 0. Result is 2 plus 0. And then 2 plus 2, 2 plus 4, 2 plus 6, 2 plus 8. I could do math. That gives us 10. I repeated 1, 2, 3, 4, 5 times. So what math does this do?
X times 5.
It's the same as x times 5. We're doing a multiplication here. We're adding the value that number of times, which is the same as multiplying. Oh, goodness. So fast. Okay, given this code segment, result is 0. We're going to repeat 2 times, and then we're going to repeat 3 times. Result is x plus result. So if we get 2 again, result starts at 0. We're going to repeat 3 times. 2 plus 2, 2 plus, 0 plus 2, 2 plus 2, 4 plus 2. And then we're going to repeat that whole thing twice. So this happens 2 times. 6 plus 2, 8 plus 2, 10 plus 2. So this, we kind of had the same answer before. We are doing double multiplication. We're doing 3 times x 2 times. So we are doing double of 3 times x. Lots and lots of multiplication happening here. Stop scrolling so quickly, please. Question 11. Procedure mystery x. Result equals 0. Repeat x times. Result equals result plus 1. Which of the following is equivalent to the value returned from mystery x? Since we're repeating x number of times and result starts at 0, let's say we had x equals 5, we're going to repeat 5 times. 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. That'll give us 5. We're always going to get the same exact value we put in. We're always going to get x. So thus far, the questions haven't been super complex, but knowing how the language works is important. So we're going to have some more practice problems next class after we finish going through this. All right, procedure mystery x comma y. Repeat y times repeat x times. Result equals result plus 1. So let's say x equals 5, y equals 2. We're going to repeat x times, and then we're going to repeat that y times. So 0 plus 1, 1 plus 1, 2 plus 1, 3 plus 1, 4 plus 1. We're going to repeat, that's our x loop. We're going to repeat y times after that. 5 plus 1, 6 plus 1, 7 plus 1, 8 plus 1, 9 plus 1. Here we are doing a multiplication again. We're multiplying x times y. Oh. All right, consider this code segment. You can assume that the mystery returns either true or false, and input list from user asks the user for several values and returns them as a list. So result list is empty for each item in input list if some mystery on that item, we will append to our result list that item. So what's happening here? We are looping for every item that the user entered. If mystery is true, we're going to add that item to the result list. So result list will contain all items from input list that meet the mystery condition. That seems like it makes the most sense because anytime mystery is true, it gets added to result list. So this code segment below, you can assume that input list from user does the same thing as before. During the AP test, will you get the exam reference sheet? I believe you will have access to that during the exam, yes. All right, so almost the same code, except here we are adding mystery of item rather than the item itself. So it's always going to be either true or false. It's going to contain the result of calling the mystery procedure on every item in input list. There we go. And our last question, what equals 1? Does equals what plus 1? V equals what plus does plus 3? Fox equals V plus what? Say equals 3. Result equals what does the fox say? Wow. So what equals 1? Does is going to equal 2. V is going to equal what plus does. That's 3 plus 3 equals 6. And fox equals V plus what? 6 plus 1 is 7. Say equals 3. And result is what does the fox say? 3 plus 7, that's 10. 6 plus 2 plus 1 is another 10. We're going to get 20. Did I do my math wrong? Am I bad at math? Yes, I am. 6 plus 2 plus 1 is not 10. That's 9. So 19 is our correct answer. I'm bad at math. That's why I'm not a math teacher. So there was our sample programming questions. We'll have more. I'll assign questions probably next time for you to practice with. I'm not going to walk through them all with you. But any questions on any of the syntax, any of the questions before we have lunch? All righty.